So we've got a couple of things we want to cover today to end off the week. First thing we want to cover is we want to cover similar figures. For example, if I have a triangle, our simplest figure we can really work with in 2 dimensions is a triangle. 3 sides and 3 angles. If I take that triangle and I shrink it, what I've created is a reduction of that triangle. It's a similar figure. All the angles are the same. Like this angle and this angle are still the same. And this angle and this angle are still the same. And the third one's still the same. All that's different is I've changed the sides. I've reduced the size of it. The same can be true if I enlarged it. The angles wouldn't change, just the lengths. The lengths change in a constant ratio. They are directly related. So let's say that this side here was 9 inches long. This one down here we'll say is 18 inches and 21 inches. In our new figure, if I know just one side, let's say I know that this one is 6 inches long, I can find those other 2 sides. I'll call them X and Y. So the first thing we have to do is to determine that the figures are similar. Well, I've told you that a few times that they are. But if I hadn't told you, how would we determine that? Well, again, it goes from the angles. It is marked that this angle and this angle are equal, and that this one and this one are equal. If 2 out of the 3 are equal, the third one must be. So the angles are the same. That tells us that these are similar. Then the second thing we need to do is figure out which sides correspond. So over here, I have the 21-inch side. Which side from the other triangle corresponds to that? The X. The 9 corresponds with 6. And the 18 corresponds with Y. Now we've looked at these proportions, and you recall these proportions have to have relationships in both directions. Here there are 2 relationships. One is sides that come from the same figure. So that would be the 9, 21, and 18 are all related. The 6, X, and Y are all related because they're from the same figure. Or corresponding sides. So the 9 and the 6, of course, correspond, and so on. So when we set up our proportion, we have to have one of those 2 relationships in each direction. Usually, I'm going to label this figure A and figure B. Usually, we have a ratio for each figure. So this is figure A here, and this is figure B. That's that first relationship. Actually, I should be careful there. Usually do that this way. And then we have also ratios for the corresponding sides. So this first one here, first ratio, is going to be the set of corresponding sides that we know in both. Let me try that again if my tongue will work. The set of corresponding sides that we have both lengths for. We have both numbers for. And what set is that? 9 and 6. Now the 9 is from figure A, so that's going to go on top. 6 is from figure B. So now over here in this ratio, the top number has to be a side from figure A, and the bottom number has to be a side from figure B. Let's say I want to find X. Is X going to go on top or bottom? On bottom, because it's from figure B. It's from the same figure as the 6. And what goes above it is going to be, has to be from figure A, and it has to be the corresponding side for X. So figure A, and what corresponds to X? 21. So we cross multiply. 6 times 21 divided by 9 makes X 14. I'm going to do the same thing for Y. 9 over 6 equals, does Y go on top or bottom? Bottom. What goes above the y? 18. Cross, multiply, and divide. Come on. 6 times 18 divided by 9 is 12. So y is 12 inches. So those types of comparisons are extremely useful. We've already seen them on roof slopes. Let's say I have a roof that I want to be at a 512 slope. Because of the height of the foundation and the height of the walls of the house, the maximum height we can have on our truss, let's say, is 12 and a half feet. So 12 foot 6 inches. What is the maximum span we can have on that truss then? Well, of course, the 512 is our slope factor. The 5 describes the rise, but the 12 describes the run. Is that this whole length? No, that's this part right here. So I'm going to label that right there with an X for right now. We're going to find that value, and we'll use that to figure out the whole span. So over here, what's going to go on top in this ratio? That's the rise, the 12 foot 6, which of course, 12.5 feet. We've got to put it all in a single unit. And then X is going on bottom, cross, multiply, and divide. 12 times 12.5 is 150. Divide by 5 is 30. So X can be 30 feet, which means that whole span can be 60 feet. Very good. Next week, we're going to do a lot of problems with those trusses. That whole packet that I just handed out to you, if you look through it, is all different types of trusses and roofs and stuff like that that we're going to use these proportions for finding. Another example we can have. Let's say we've got Jasper. And Jasper's mom wants him to help out with a tree in their yard. It's a tree. So anyway, Jasper's mom wants him to cut down this tree. So Jasper's sitting here with his chainsaw, cutting down the tree. Of course, it's Jasper, so, you know, he's probably sawed half his leg off and there's blood spurting out. We won't get graphic. So anyway, yeah, is Jasper going to whack the hole in the side of his mom's house? Well, how would he be able to tell? Well, let's look at this. Let's say that from the center of the tree to the side of the house, Jasper measures it out, and it is 87 feet. Jasper, though, does not know how tall the tree is. He's not going to climb up there to measure it, so how can he estimate it? Well, since Jasper's only been home for the day, the sun is still shining on his mom's house. And so the sun shines and creates a shadow of that tree on the ground. What's that? Did you? Let's say the shadow of the tree, from the center of the tree, this shadow is 120 feet long. Jasper, how tall are you? 5'8"? You're a little taller than that, aren't you? I would have put you about 5'9" or 5'10". Are you? Okay. Well, let's say Jasper, we're going to make this a little easier on us. Jasper puts a tall hat on that makes him exactly 6 feet tall. And Jasper measures his shadow from the sun. So he's 6 feet tall. I'm going to put that in different colors. He's 6 feet tall, and his shadow is 8 feet long. How tall is that tree going to be? We're going to call that X or H or whatever you want to call it. What we're going to do here, of course, we have two relationships. We have the two numbers that go with Jasper and his shadow. Then we have the two numbers that go with the tree and its shadow. Those are related one way. But then we also have a second relationship. We have the vertical dimensions and we have the horizontal dimensions, or the actual objects and the shadows. So let's do Jasper first. We got the 6 to 8. Those both describe Jasper. For the tree, we've got the shadow of 120. Is that going to go on top or bottom over here? The bottom, the 120, that describes the shadow. The 8 describes Jasper's shadow. So the X will describe the actual height of the tree. The 6 was the actual height of Jasper. So we will cross multiply and divide. 6 times 120 divided by 80 is 90 feet. Is the house a goner? Might punch out a window or something with the tall branches, but won't do a lot of damage. You're going to hit it by 3 feet. All right, so those similar figures are things that we can use for almost anything. And it don't have to be two-sided figures or two-dimensional figures. It can be as complex as we want to. It doesn't have to be triangles. We can have multi-sided figures. Like that. Pretend those look the same. Here. That's a little bit closer. Now again, we need to know what matches up. So let's say I tell you this angle and this angle match up. This angle and that angle match up. These two. And I'll just give you that those are similar figures. But we need to know at least some of the angles so we know where things orient. You'll see these two are not in the same orientation. So you can't just match them up. So you've got to be very careful what sides you match up with each other. So over here, let's say that this is 3 inches. We'll call this one X inches. This one will be 6 inches. This one will be 9 inches. We'll call this one Y and this one Z. Over here, let's call this one, well, let's call this one 7 inches. This one down here, we'll call 21 inches. Yeah, I'll be nice. Make that a little bit more realistic. We'll call that 15 inches. Let's make this one here is going to be 15 inches. This one here is going to be M. And let's see. Ever those days where the brain just doesn't want to work? We'll call this 49 inches and 54 inches. In your notes, find those missing sides. X, Y, Z, and M. Doing on this one so far. So we need to find at least one set of corresponding sides that we have the number in both figures. Did you find one? The 9. I labeled that wrong, didn't I? Get back here. I labeled the 15 on the wrong one. This should have been M and this should have been 15. I'll give you a minute to finish that. Let's take a look at these now quick. What's that? Some of the numbers didn't match up? This one for you. Okay, so let's look at this. We have pairs of sides that correspond. We actually have two of them. We have this 3 here that corresponds to that 7. But we also have this 6 here that corresponds to this one at 14. We have to make sure that those are the same ratio to make sure that these are similar. The way I gave it to you in the first shot there, they weren't similar. It wouldn't work. Is 7 to 3 equivalent to 14 to 6? Well, we can just do a straight cross multiplication. 3 times 14 is 42. 7 times 6 is 42. Since those are the same, those are equal ratios. So now then, we can use either one of them. I'm going to use a 7 over 3 just so I'm working with smaller numbers. And how about for x? Is x going to go on bottom or top? Yeah, it's from the same figure as the 3, so it goes on bottom. What goes above it? Well, the corresponding side from the other figure would be the 15. If we cross multiply and divide, 3 times 15 is 45. Divided by 7 is 6.4285743 approximately. 6 3/7 would work too. Continuing with that 7 over 3. Let's find y. Well, y is also from the same figure as the 3, so it goes on bottom. Y corresponds with 49. It's next to the 3, the 49 is next to the 7. We cross multiply and divide here. 3 times 49 divided by 7 is 21. Do the same thing for z. Z also goes on bottom, and it corresponds to the 54. 3 times 54 is 162. Divided by 7 is 23.142857143 approximately. And finally, we need to find m. We've still got the 7 to 3. This time, m comes from the same figure as the 7, and it corresponds with the 9. So we cross multiply and divide. 7 times 9 is 63. Divided by 3, m is 21. What do you think? Good stuff? Better than a sharp stick in the eye? Let's shift gears a little bit. Little review of some operations. Things like 8 feet 9 inches plus 4 feet 8 inches. When we go to add those, what do we get? What do we do? Tell me how to do it. So we've got the 9 and 8 make 7, 8 inches, 17 inches. Just like any other addition, we start at the right, work our way back to the left. Now that is bigger than a foot. That breaks down into 1 foot and how many inches? 5. Just like any other addition, we keep part of it. We're going to keep the 5 inches, and we carry part of it. We carry the 1 foot over into the foot digit. 1, 8, and 4 make 13 feet. Look familiar? How about 7 pounds, 13 ounces plus 2 pounds, 11 ounces? Start on the right, work right back to the left. 13 and 11 make 24. Is that bigger than a pound? How many pounds can I get out of there? 1 pound. 1 pound is how many ounces? 16. So how many would be left over? 8 ounces left over. So again, we keep the ounces in the ounces column. 8 ounces, we carry that 1 pound. 1, 7, and 2 is 10 pounds. Let's do sum of 8 feet 3 inches minus 5 feet 9 inches. We go starting on the right, working our way back to the left, we're going to subtract. What is 3 inches minus 9 inches? Can't do it. What do we have to do? Borrow from me. At 7 feet, what's the 3 become? 15, because that 1 foot was 12 inches. Now we subtract. 15 minus 9, 6 inches. 7 minus 5 is 2 feet. We may have 5 pounds, 2 ounces. Let's subtract 2 pounds, 15 ounces. Tell me what to do. Borrow from the 5. That's going to become 4 pounds. The 2 becomes 18 ounces. Now, because that's plus 16, right? Now, 18 minus 15 is 3 ounces, and 4 pounds minus 2 pounds is 2 pounds. Not so bad. Okay, so multiplication is usually where we start to have some confusion. There are people with addition and subtraction that prefer to turn it all into inches, like someone mentioned out there. You have to convert from feet and inches into all inches, and then you have to convert from inches back to feet and inches. Because when you're on a construction site, if you yell out to somebody 84 inches, well, not necessarily. It's a lot easier to yell out 7 feet. That's what they're going to be used to hearing. When it comes to multiplication, however, we don't use the dual units. At least not in the same way. Let's say we have 7 feet 3 inches times 2 feet 6 inches. If we multiplied there, we'd have to do the 6 inches times 3 inches, but we'd also have to do the 6 inches times the 7 feet, which would give us 42 foot inches. A foot inch is actually a unit. We just don't use it for anything anymore. It's been outdated for a long time, for hundreds of years. A foot inch is just a strip that's a foot long and an inch wide. That's it. We don't use them for anything anymore. We use all square inches or square feet. They stopped being common in use several hundred years ago. Yes, sir. In what situation? In area? You have a rectangle that's 7'3" by 2'6". Now, so when we go to multiply these two dimensions, we would either convert it all into inches or all into feet. How would we convert those into inches? So 7 times 12 is 84 plus the 3. 87 inches. Kind of like converting a mixed number into an improper fraction. So the 2 feet 6 inches, 2 times 12 is 24 plus 6 is 30 inches. So now we have 87 inches times 30 inches, which is 2,610, isn't it? Square inches. Yep. If we wanted to convert that all into feet, how would we do it? Well, 7 foot 3 inches, we would convert it. An inch is a 1/12 of a foot, so that'd be 7 3/12 of a foot, or 7 1/4 feet. 2 foot 6 inches would be 2 6/12 of a foot, or 2 1/2 feet. And we multiply. 7 1/4 times 2 1/2. We get 18.125. And that is square feet. Now, a little note here, by the way. What's our conversion from square feet to square inches? Yeah, there you go. It's not 12, it's 144. So to get from 18 1/8 basically is what that is, to our square inches, we would have to multiply by 144. Good, you guys remembered that. A lot of groups forget that it's a different conversion for square inches. Sure. So what we want to look at here for operations with measurements is not taking one measurement times another measurement. It's going to be something like this. 3 feet, 11 inches times 5. Let's say you have pieces that are 2 feet, 11 inches long, and you need 5 of them. You want to know what's the total length of material you're going to need. We're going to ignore saw curves. So we could convert that all into inches, multiply it by 5, and then convert it back. Or we can just go ahead and multiply it the way it is. What is 5 times 11 inches? 55 inches. Obviously more than a foot. How many feet can I get out of 55 inches? 4 feet, which would be how many inches? 48. So how many are left over? 7. So we keep the 7 inches, and we carry the 4 feet. Now we have to do 5 times 3 feet, which is 15 feet, plus 4 is 19 feet. You could have turned that 3 feet, 11 inches into 47 inches, multiplied by 5, which would give you 235 inches, and then convert it back down. But converting this back down into feet and inches can be kind of a pain. So for me, it's a lot easier to leave it as feet and inches, leave it in the dual units to multiply it out. But some of you may find it easier to convert. Same type of thing goes for when we divide. We might have 29 feet, 8 inches. So we have 29 feet, 8 inches of material, and we want to cut it into 4 equal pieces. How big is each piece going to be? So remember, division is the only operation that goes left to right. So 4 goes into 29 how many times? 7. That means 7 feet. What is 7 feet times 4? 28 feet. How much is left over? 1 foot. Now, before we bring down the 8 inches, we need to convert 12 feet into inches. Bring down the 8 inches to make 20 inches. What is 20 inches divided by 4? 5 inches. So each piece would be 7 feet, 5 inches long. Again, you could convert that all into inches. 29 feet, 8 inches would be 356 inches. Divide it and then work with that. I think it's easier to work with it in dual units. We can run into some tricky ones like this. We could have 31 feet, 10 inches divided into 7 equal pieces. What is 31 divided by 7? 4. What's 4 feet times 7 would be 28 feet. So how many feet are left over? 3 feet. We convert that to what? 36 inches. Bring down the 10 inches to get 46 inches. 46 divided by 7, 6.57142857, approximately, right? So we've got 4 feet. We have the 6.5714. Now I want to take a look at this here. That 6.57142857 inches. Obviously, that doesn't appear on your tape measure anywhere. So let's say we take a number like that, 6.57142856 approximately inches. And let's say we're doing something where we want to measure to the nearest 16th of an inch. How would we convert that to the nearest 16th of an inch? Well, the 6 whole inches, that's not going to change. All that we're really working with is the decimal here. Now I'm going to make that into a fraction the easiest way I know how. Put it over 1. It's now a fraction. It's not a proper fraction by any means, but it's a fraction. Right now it has a denominator of 1. I want it to have a denominator of 16. How do I make it have a denominator of 16? Multiply by 16. If I multiply the bottom, I have to multiply the top. So 1 times 16 is 16. 0.57 14286 times 16 is 9.1429. We'll just go with 9.14. Now that 9.14 is telling us that this is between 9/16 and 10/16. Which one is it closer to? How do you know it's closer to 9? Yes, it's 0.1. If it was 0.5 or bigger, it would go up to the larger one. It's less than 0.5, so it goes to the smaller one. So that is 6 9/16 inches to the nearest 16th. Actually, it would still be 18 30-seconds. Because if it was the 32nd, it'd be 18.28, which would still round down to 18. It would be 37/64. Okay. In your notes, try this. 5.813 inches. Try to convert to the nearest 32nd of an inch. Okay, so we take off the 5. 0.813 over 1. What are we going to multiply by? 32. So 0.813 times 32 is 26 point what? 01. Okay, so that does round to 26, which is going to be 13/16. So 5 13/16. Now I do get asked, well, why did we reduce that when we asked for it in 30 seconds? Well, because 13/16 is still a 32nd. It's just been simplified. Okay. What I want you to do in your big book, page 512 to 513, exercise 23-3. And then in the packet, I want you to do, here, let me grab that just a second here. I'll give you guys the last 20 minutes here, 19 minutes to get started on those. I'll answer any questions as they come up, and then we'll call our day.